Hi friends, welcome to Acube. In this session, we are going to solve some problems. So, problem 1. A person uses concave mirror for shaving. Where should he position his face in front of it? Okay, when we take a concave mirror, this is our principal axis, this is our focus, and this is our center of curvature, that is C. So, when we look like this, what we need for shaving? We need an enlarged image of our face and we need an erect image. So where do a erect image and an enlarged image forms on a concave mirror? Yeah, definitely. When we keep an object between focus and the pole, somewhere over here, we get an enlarged image. How? When we take a ray that is parallel like this to the mirror, it will pass through the focus like this, and when we take a ray that had been passes through the center of curvature like this ray will pass through the center of curvature. Yeah, so what we get? The topmost point will be somewhere here. We do not have that much of gap here, so the object will be some like this. It will enlarged, so it is erect and we need this. So he should position his face between focus and pole of that concave mirror. So somewhere over here, he should position his face between focus and pole. So now problem 2. The power of a lens is -2 diopters. Is the lens convex or concave? Okay, what is basically a diopter? Diopter? Yeah, it's nothing but 1 by focal length, that is focal length in meters in this, is equal to diopter. Okay, so now they are given the diopter in this case, that is the diopter is equal to -2 the focal length. So focal length is equal to 1 by -2. So what is -1 by 2? Yeah, it is nothing but -50 centimeter. What does this -50 centimeter tell us? That is the -50 tell us that this lens is a concave lens because focus equal to -50 centimeter, basically a concave lens as a focus minus, because when I take a concave lens, when we take some ray, parallel ray, it will it had been passed through the focus. So if we take any ray, that will pass like this. Okay, so basically a concave lens has a focus that is minus, because when you draw a graph over here like this, that is like this is up is positive and down is negative, and right is positive and left is negative. So the focus of a concave lens is in a negative side, so we are getting -50 centimeter. Okay, so our answer is that is the lens is concave lens. Problem 3. The magnification of a plane mirror is +1. What does this signify? Okay, basically let's take a plane mirror. And we also know that the magnification is nothing but h by h, that is the image size by the object size. Okay, now the h size is object size. Okay, Okay, and what happens in a plane mirror? Let's take a simple arrow mark, and when we take a ray like this, it is going to reflect like this, following the principle. This angle of reflection, the angle of incidence is equal to angle of reflection. So this ray going to go like this, and the final, it will be something like this. And we already know that this distance, the object distance from the mirror, is equal to the object distance, the image distance from the mirror. Yeah, and we already know that the image and the object will be same size. If you take the object size as 3 centimeter, that is 3 centimeter, and the image size will be also 3 centimeter. So what will be the magnification in this case? Yeah, it's nothing but the object size by the image size by object size, that is by nothing but 3 by 3. It will become 1. So we get, that is, magnification is plus 1 because we get plus. Okay, so this is the plus 1 signifies in this case. Problem 4. You have a spherical mirror. The image of an object placed in front of it, front of the mirror, is virtual. If the position of the object is changed, the image remains virtual and erect. Is the spherical mirror is concave or convex? Yeah, it is basically a concave mirror because it is basically a convex mirror because the convex mirror produces only virtual image wherever we keep the object. Okay. Problem 5. In this question, they are given us a diagram, that is, the diagram is something like this. We have a swimming pool over here, and a bee is seeing from the top. And what the surface of the swimming pool will look, how it will look for the bee. It will look like this, or it will look something like this, or it will look same as this, flat. How it look? So basically, let's take some rays. What happens to a ray? So when we take this ray and when we draw normal, it will bend away from the normal and reach its size. When we take this ray, this will also do the same. It will bend away from the normal and reach its size. A straight ray would not deflect, so it reaches like this. So it will happen continuously. Yeah. So this is going to be happen. So what does the bee know? Bee do not, the bee's brain do not know that this rays or that is light will bend. So it assumes that light will always come in a straight line. So its brain will draw a ray something like this. Yeah. Because this ray length and this ray length will be equal, so if it comes slanting, the distance will be reduced, so it will not touch the surface. Okay, and the bee's brain will infer that this surface is something like this, so it will get the surface as some above, so the surface will look like this. So this is the same phenomena happens with when you see water in a tumbler. The tumbler surface um, would show you that it comes like something forward, so it is the same phenomena like this. So this is the answer, that is the swimming pool floor will look like this. So friends, now problem 6. A concave mirror produces 3 times magnified real image of an object placed 10 centimeter in front of it. Where is the image located? Okay, let's draw the concave mirror. You can also do it with the help of a formula, that is V by U equal to H by H dash. That is also very easy, but in this time I'm going to prove with two methods, that is using geometry and using, that is V by U equal to H by H dash formula. Pole, focus and center of curvature. And in the question they have said that a concave mirror produces 3 times magnified real image. This is an important word, that is real image. Because when we want to get a real image, the object must be placed behind the focus of this concave mirror, because when it is between the focus and the pole, the image will be virtual, that is it will form behind the mirror. Okay, so the object must be kept between f and f beyond f. Okay, so let's place object over right here, and they said that we get a 3 times magnified real image. So let's take a ray like this, pass through the focus. Let's take this ray, pass like this, so it forms object beyond C, that we already know that it will form an object beyond C. So this is the image formation, and this is in the ratio of, this is 3 times magnified. So when this is 1, this is 3. Okay, so they already tell us that the object distance from the mirror is 10 centimeter. So this distance will be 10 centimeter. So from this, what we can infer, that is when we take this triangle and this triangle separately, it will something look like this. Yeah, this angle and this angle must be equal, because angle I, that is angle of incident, equal to angle R, that is angle of reflection. So these two angles are equal, and this angle is 90 degree because I am placing the object at 90 degree, and the image will be also at 90 degree. So this is also 90 degree. Okay, this is the arrow mark. So this distance, let mark the triangles, let give names to the triangles. That is EB is equal to 10 centimeter. Yeah, so if this is 3, this is 1, means when this is 10, means dB will be definitely equal to 30 centimeter. This is a simple geometric proof. Okay, let's prove this using formula, that is image distance by the object distance is equal to image height by the object height. So what is the image distance in case? We don't know. We want to find the image distance, because they are asking in the question, that is where is the image located. So means we know U, that is object distance, that is this 10 centimeter. Yeah, we know the image size, that is we know the object size, that is 1, and the image size is 3. This is nothing but 3. So V is equal to 3 into 30 centimeters, that is V is equal to 30 centimeter. Yeah, this is the answer for this question. It is only 30 centimeter. No, it is minus 30 centimeter, because this 10 is not ordinary 10, because the object distance is on the left side. Yeah, the object is kept left side of the mirror when we draw a graph like this. Like this. This is left side of the mirror, that means this is negative, that means the object distance is negative. So we should substitute minus 10 over here. The image distance is positive, the image size is positive. Sorry. Yeah, the image size, so it will become minus 30 over here, because that means it signifies, this minus sign signifies as that is the image is formed left side to the mirror. So where is the image located means it is located minus 30 centimeter, that is we should not say minus 30 centimeter, we should say 30 centimeter to the left side of the mirror. Yeah, and we should not tell the distance in minus. Okay, so friends, answer for this is minus 30 centimeter. Okay, and next problem is, so problem 7 is, what happens when we cover one half of any lens or mirror with black paper? Do we get a full image? Think about it. We will answer this question in our next video. If you like this video, like, share and subscribe to my channel. Jai Hind, Vande Mataram.